Seeing the spaceship rolling out on the tarmac and over to the other hangar, she really looks like a spaceship. It really makes all that hard work to design and build come to life. This is a huge milestone, and yet this is just one part of the story, because what you see here is only a fraction of the work that has been happening to prepare this spaceship for flight. My name is Gabriel Williams. I'm the Senior Chief Engineer for SpaceShips at Virgin Galactic. For me as the engineer, testing is the most exciting phase. There's so many types of testing we do in parallel in so many locations to make sure the spaceship is operating exactly as we expect it to. First, materials and components testing, which we've been doing the last couple of years here in California at our safety and test center, as well as other locations across the country. Second, systems testing, and that happens on our Iron Bird as well as on test benches in our engineering headquarters in Orange County. Third, we do full-scale structural tests in San Antonio at Southwest Research Institute. And fourth is integrated vehicle ground testing out at our spaceship factory in Arizona.
Hi, I'm Chris Ralph. I'm the Director of Test and Evaluation here at Virgin Galactic's Safety and Test Center. Let's take a look around. In these environmental test chambers, we test the components that we use to build up our spaceship for both temperature and humidity far beyond the extremes that it will experience in space. We qualify the components that go on the spaceship, anything from mechanical systems, avionics, mission systems, flight control systems as well. And what qualification does is it tells us that the design is good. We will exercise the unit and stress it under vibration, thermal, and other environments far beyond what's required during flight so that we know that it'll be safe. The Iron Bird is a test asset that we have here at the STC, which is the first time where all of the components are put together into one system.
This asset is so valuable to us. On Unity, we had to test everything when we put it all together on the ship, and that testing took months. Here, we can do that testing early, and we can find problems before we build them into the ship and solve them ahead of time before they get built.
What we do is essentially build the spaceship here on the Iron Bird. We use all of those components together, and it's the first time where we show that the systems work together and play in concert.
Downstream, we're going to be able to use this asset to perform upgrades to the spaceship and test them before we try to implement them on the spaceship. Using the Iron Bird has huge value to us now, and it's going to have a long-term benefit for Virgin Galactic. While we're doing all of this system integration testing here in California and Phoenix and other places, we're also doing lines of structural testing. We do element level tests where you take structural components and put them together in smaller, more bite-sized chunks of structural tests. Those culminate with what we call a static test article.
Down in San Antonio, so that's a structure of the spaceship. So it's a copy of Delta One, and we'll put that inside load frames, twist, push, pull on it to ensure that the structure is capable.
We actually just finished last week our static test article of the horizontal stabilizer. That test is a full-scale test of the entire HDAB where we bend it and make sure that the flight controls all move as they're expected to and that they can withstand ultimate load.
Because of the component qualification acceptance, system level testing, static test articles that we've worked together give us a really excellent baseline for us to be able to fly safely and repeatably.
My name is Jeremy Gadgeter. I'm the Vice President of Mission Operations. I'm here at the Spaceship Factory where we do our integrated vehicle ground tests. There's up to 64 of these tests that we're going to do on the vehicle.
We run checks on wiring harnesses, plumbing lines, instrumentation, components, and more. These are production acceptance tests that check end-to-end use of our subsystems. For example, each batch of wire harnesses that run from the cockpit to the flight controls on the feather boom. The second set of tests is what we call our integrated vehicle ground tests. These are our systems of systems checkouts. We're checking the integrated response of multiple systems through our verification.
Some examples of the integrated vehicle ground tests, we're going to measure how long it takes for the landing gear to deploy and then to retract. Same thing with the feather. We have a model of how long it takes the feather to extend and to retract. But again, we want to validate that on the ground test here in this hangar.
As the chief engineer, each of these tests is very important to me in putting together the puzzle pieces of ensuring that the entire spaceship and every aspect of it is tested and we're confident in how it's going to perform in flight. We need absolute precision in our predictions to be able to fly, and that's what I strive for. And that's why we test spaceships.